All right, number 8, we're supposed to prove that angle 1 is congruent to angle 2. Here's the plan. If we can show that triangle AB is congruent to triangle CDE, then we'll be able to deduce that this side and this side are congruent to each other because those are corresponding sides of the yellow and blue triangles. And if you can do that, then by the base angles theorem, angle 1 will be congruent to angle 2. Recall that the base angle theorem says if a triangle is isosceles, then its base angles will be congruent. So if we can show that this triangle in the middle is isosceles, then we'll be done. Because remember what they asked in this problem. Prove that angle 1 is congruent to angle 2. All right, so let's prove that with the given information, the yellow triangle ABE, or triangle AB, is congruent to the blue triangle DCE. Here we go. So let's start with all the given stuff. These sides are congruent, AB and CD. Angle A is congruent to angle D, and then the double arcs, angle AEB and angle DEC. That's all given. And yep, my kids, you could have just pointed to the picture and said all that stuff given. But we're trying to prove that the yellow triangle is congruent to the blue triangle, and we already have 3 pieces of congruence. So remember what your options are for proving triangles are congruent. Hypotenuse leg theorem, the SSS, SAS, ASA, and AAS. These are our options, and already, before we've even done anything besides note what the given is, we have one of these situations where we can already prove the triangles are congruent. Which theorem will we be using? Well, we have 2 angles congruent to 2 angles, so there's 2 pairs of angles, and 1 pair of sides. So it's going to be one of these 2. Now, this side is included between the 2 angles, which means this side will actually be touching both vertices of these angles. Whereas this case, the side is not included between the 2, so this side will only be touching one of the angles and not the other one. When we look at our picture, our side is touching the vertex of this angle, but it's not touching the vertex of this angle. So this side is not included between these 2 angles, like side AE would have been. This is a case of AAS. All right, and now that we know the triangles are congruent, the yellow one and the blue one, we can work on showing that this is an isosceles triangle, after which we'll use the base angles theorem. All right, well, this side's triangle's left leg is side BE, and you can see that that's the second and third letter, and that corresponds to side CE, which is the right side. So we can go right to it. Statement 3. Those 2 sides are congruent, which makes this an isosceles triangle. And now, since this is an isosceles triangle, the base angle theorem tells us that angle 1 and angle 2 are congruent. Base angles theorem. So all that we're left with is what's the reason for saying that these 2 sides here, side BE and CE, are congruent? And this is one of the new things from section 5.7. You have the option here of saying, since these triangles are congruent, their corresponding parts are congruent, and that is the definition of what it means to be congruent triangles. So definition of congruent triangles. Or if you prefer, you can say that the corresponding parts of those congruent triangles are congruent. So CPCTC says that the corresponding parts, like second, third letter, segment BE, and segment CE, those corresponding parts of what are CT congruent triangles, those parts are congruent. So your options are CPCTC, or to just say definition of congruent triangles. All right, that's how we do number 8 in 3 steps beyond the given. I hope that helped.